Jai Hind everyone. Today in this part we are going to talk about decimal expansions of real numbers. We all know that there are several types of decimal numbers. Let us take an example. For example, if I'll take a number say 13 by 50, if I'll calculate its decimal form, we'll get the decimal form of this number as 0.26. Same way, if I'll take 1 by 4, the answer will come as 0.25. Similar to that, if I'll take 1 by 8, the answer will come as 0.125. So these are the numbers which when you divide will get a particular decimal number, and after this the remainder becomes 0. Now let us take another example. For example, if I'll take 10 divided by 3. If you start dividing it, you will find that this number is coming like 3.3333 and it goes on. Same way, if you take 20 by 6, again you will be getting 3.3333 and so on. Same way, if you will take the value as 15 by 11, you will obtain that this number is 1.3636 and it is going on. So from here you can find out that there are two different kinds of decimals which we are obtaining over here. One which is getting terminated, that means the remainder became 0 after certain places of decimals. So these kind of numbers are known as terminating decimals, whereas these numbers which we have seen that are not getting terminated, in which a particular number or a set of number is continuously repeating, are known as non-terminating decimals. So broadly, decimals are classified into two parts. One is terminating, another is non-terminating. Now, out of non-terminating decimals, if you will see over here in all these questions or all these examples, the decimals have either a particular digit or a group of digits repeating continuously. But there are certain examples for which you will find that its decimal expansion is neither terminating nor repeating. For example, if I take a number, say root 2, and by using the division methods of finding square root, which we all have studied in class 8, if you calculate its square root, you will find that it is coming 1.4142 135 and so on. When you will find few more digits after it, you will find that none of the digit or a group of digit is repeating over here. So on the basis of this, the non-terminating decimals classified into two forms, repeating and non-repeating decimals. Over here, whichever examples were there were the examples of repeating decimals, whereas this is an example of non-repeating decimals. So we have classified the decimals into two parts, terminating and non-terminating. Further, the non-terminating decimals are subdivided into two parts, repeating and non-repeating decimals. Now, the decimals which are either terminating or non-terminating but repeating, but repeating all these types of decimals are called rational numbers. That means these decimals can be represented in the form of p by q, whereas the decimals which are neither terminating nor repeating are known as irrational numbers. Irrational numbers. So we can find out whether a number is rational or irrational by looking at their decimal expansions also. I'm just reiterating my words that the terminating decimals are rational, non-terminating decimals which are repeating are rational, but the decimals or the decimal expansions of those numbers which are neither terminating nor repeating are known as irrational numbers. For example, you can find out the values of root 2, root 3, root 5, etc. You will find that the decimal expansion of all these numbers are neither terminating and nor repeating. So all these are the examples of irrational numbers, whereas all these numbers which we have taken over here as an example are the examples of rational numbers. So I hope you all have understood the difference between the rational and irrational numbers in terms of their decimal expansions. Jai Hind.